Here's another example. This time we are given the equation in standard form. We have 16, which is our k. And notice that this says x plus 4, and the form is supposed to be x minus h. So h is going to be negative 4 here. All right, so my vertex is the ordered pair negative 4, 16. My a is negative. Right, a is less than 0 because it's equal to negative 2. Therefore, this thing is concave down. All right, if it's concave down, then that tells us that our vertex is a maximum. It's the highest point. All right. Find the axis of symmetry. Well, the axis of symmetry is x equals h, and in this case, that's negative 4. All right, domain, same as always. X is an element of minus infinity to infinity. Range. So if the highest we can go is negative 4, we start at minus infinity, and we go to negative 4 and include that. Then the last step says find the intercepts. So I go back and find my equation here. I need to let y equal 0 and solve for x to get my x-intercepts. Okay. So I'm going to move 16 to the other side. Divide by negative 2. So I have 8 equals x plus 4 squared. Take the square root of both sides. When I do that, I get plus and minus. So I have plus and minus square root 8 equals x plus 4. I'm going to move the 4 to the other side. And then 8 is 4 times 2. So I can make that 2 root 2. Okay. So plus and minus 2 root 2 minus 4. All right. If I want my y-intercept, then I need to let x equal 0. So I have y equals 16 minus 2 times 0 plus 4 squared. 4 squared, 16. 2 times 16 is going to be 32. And this is going to result in a negative 16. So my y-intercept is the point 0, negative 16. Okay, once again, let's go over to Desmos, where I have already plotted the function. Here's the equation. The vertex is indeed at negative 4, 16. I cross at negative 1.172 and negative 6.828. If I go over to the calculator, it's minus 4. Okay, so minus 4. Minus that, I get minus 6.828. And that's here. And then I'm going to do the plus. That should give me the other one. Negative 1.17. Negative 1.17 looks good. I can also, I haven't done it yet, but I can plot the axis of symmetry, right? X equals, and in our case, this was negative 4. Right, there's our axis of symmetry. And this is concave down. Vertex is a maximum, right? So our the domain is all real numbers, and then the range goes from minus infinity up to negative 4. So all that checks out. Everything looks good. Hopefully that helped with understanding quadratics. In the following exercises, we're going to be asked to come up with the equation for the quadratic function in standard form given a graph. So off the graph, what information can we get? Well, it looks to be that this here is the vertex. And the vertex is the point HK. That's two of the things that we need here, right? H and K. The other thing we need is this value of A. Now, we can't just get that off the graph necessarily, but we do have a very well-defined point here, which allows us to plug in. So let's see what happens. So let's start with the vertex. So our function with that plugged in is x minus 2 squared minus 2. Now, if the point 0, 6 is on the graph, then I should be able to plug it in. So when x is 0, y should equal 6. So 6 equals a times 0 minus 2 squared minus 2. I'm going to move the 2 to the other side by adding, becomes 8. And then I have negative 2 squared here. That's going to be 4. So I have 8 equals 4a. Divide by 4. And a equals 2. Once I have a, then I can finish writing out my equation. It is 2 times x minus 2 squared minus 2. And just to make sure that that looks good, let's go ahead and plot that function and make sure that it does indeed pass through these 2 points and produces the same equation or same parabola that we had before. So let's go ahead and jump over to Desmos. 2 times x minus 2 squared minus 2. So it passes through the point 2, negative 2. We had that as our vertex before, and we pass through the point 0, 6. So indeed, this does look like the same parabola that we had before. All right, that's great. Let's take a look at one more example here. Again, we're given 2 points. This time, instead of the y-intercept, we're given the x-intercept. But we can still do the same process. So the vertex, once again, is hk. So my function f of x is a times x minus h squared plus k. Substituting in, we have x minus a negative 1 squared plus a negative 4. So this becomes x plus 1 squared minus 4. So this is our parabola currently. We would like to know what is a. We have the point 3, 0, so let's plug that in. That says that y is 0 when x is negative 3. Okay? So we have negative 3 plus 1, that's negative 2. I'm going to go ahead and move this negative 4 to the other side by adding. Negative 2 squared is also 4, so I have 4 equals 4a. Dividing both sides by 4, I get a is 1. So my final equation is f of x equals 1 times x plus 1 squared minus 4. And because it's a 1 out front, I'm going to go ahead and not even write it, right, because it should be understood. So I'm going to use this as my equation. So let's plug that into Desmos and see if we indeed get what we expect. All right, so I went ahead and plugged the equation into Desmos. This is the parabola that I'm getting. My vertex is negative 1, negative 4. And my y-intercept is negative 3, 0. So let's double check. So I flip back here. Negative 1, negative 4 was the vertex. Negative 3, 0 was the x-intercept. All is right with the world. And that'll conclude Quadratic Functions, Chapter 2.2.